Hi, I'm Colton.
And I'm Matt.
And this is Math Notebook. So today we're going to be teaching you about chi-square statistics and tests.
A chi-square test is a test that shows you the relation between one thing and another and whether one variable is dependent on the other.
Let's get started. So doing a chi-square statistic, you're going to need a TI-83 Plus, or at least that's what we're using, but any standard graphing calculator that has the matrix function and chi-square testability will do the same thing. So we're using a TI-83 Plus, but other versions work as well. And we have our stats right here. We have male, female, the total for each column, and then the different Democratic parties, or not Democratic, but the different political parties such as Republican, Democrat, and Independent. And so what we're going to be doing is testing whether there's a correlation between one's gender and the political party they vote for. So we have statistics or data taken that shows the amount of males out of 400 that voted for Republican, out of Democrat out of total 400 as well, and everything like that. And it's important that you have your totals as well. But first we're going to go to our calculators to find first what the chi-square statistic is. And that's the symbol for the chi-square statistic, which is an X that's kind of squiggly and then a straight line with the square. So we're going to press second X to the -1 where it says matrix. And then we're going to go over to edit. And then table A should be empty for you or whatever it is. And so first you're going to see 2 times 3 or any number up here. We have 2 columns, categories going to the right and left, so male and female, so we're going to put 2 here, and then 3 across. But this is not counting the totals. And so then you have a chart that fits one below, and so we're just going to type in all the data. 200, 150, 50, 250, 300, 50. Okay? And then what you're going to do next is you're going to go to Stat, which is right under Delete, and go all the way to the right under Tests. And then you're going to scroll down till you see the familiar symbol that we wrote down, the X to the squared test with the squiggle, which looks familiar to this. So we're going to do that, Enter, and then it's going to ask what you observed, and we put it in Table A. If you put it in Table C, then you can put Table C. Expected, this is going to put its expected values in table set B, and we'll explain more what expected values are in another episode. And then we'll calculate. And so then we're met with some data, which is X, or the chi-squared number is 16.2037037. So we're going to write that down using significant figures, which is going to give us 16.2. Alright? And then we have to find the p-value. And the p-value is the probability that it can be proven wrong. So what we're testing for is null hypothesis and alternate hypothesis. And so saying that gender is dependent upon voting preference, or there's a correlation between the two, how can that be proven wrong? What is the possibility that can be proven wrong? And so the way I've remembered that, and so if you have a low p-value, that's a good way to remember that you're going to accept an alternative hypothesis that is saying that they are dependent on one another, and we're going to set our significant rate at 5%, which is what it's set at, and then we see that our p-value is 3.029, and so using significant figures it's 3.03%, and therefore it crosses our hurdle rate, and we can see that there is a dependent correlation between one's gender and what they're going to vote for.
Now it's time for Quick Tip of the Day with Matt. So you might be wondering what Colton was talking about the null hypothesis and the alternate hypothesis. So what a null hypothesis is it's the boring thing. You don't want to, and it's the original, like, I need to start.
Right. Just say the null hypothesis is what is already generally accepted,
Yeah.
such as both variables have no correlation with one another. I'm gonna do some just a sound marker. The sound marker's like when I see the audio waves in Vegas, I'm like, that's where we screwed up at. Alright. 3, 2, 1.
So you might be wondering what Colton was talking about when he said null hypothesis and alternate hypothesis. Well, what he was saying is when you reject the null hypothesis, you're rejecting that the original thought, which is both items have no correlation at all. So if you go in, you think that men and women, their gender has no correlation to their voting patterns. But if you're so it's really boring, like just thinking about that, like nothing relates to each other. But the alternate hypothesis is that both things do correlate. So when you have enough data to reject your null hypothesis, that's when your alternate hypothesis comes around. So your alternate hypothesis is men and women. With men and women, the gender does play a role in your voting patterns. So now you might have noticed on the calculator there was a third number. It was DF, which stands for degrees of freedom. The degree of freedom is how, it's what you're restricted to. So, like if you're writing numbers in on a graph, and you have your totals. So let's say you have to reach a total of 30 here on this column, 25, 10 here, 40, 15 here. Then you can write, let's say, 5, and then 24. And then you're kind of pigeonholed because you cannot make up numbers here. This has to be 1. This has to be 14. This has to be 16. And this has to be 5. So you kind of have to fill in your, like you can only, your degrees of freedom are 2 because you have to fit these numbers. Okay, so now we're gonna look at another chi-square problem. This one deals with new textbooks and old textbooks. So if we're gonna do a test to see if students did better with the new textbooks as opposed to the old textbooks. So as you can see with the new textbooks, they did a test with 20 students that shows people below average, at average level, or advanced. So we're gonna put these numbers into our chi-square. So matrix. As you can see, they're already in there. And now we go to second stat. Just stat. Calculate. And so we got a p-value of 0.239 or 23.9%. This, and our chi-square value is 2.85. So we have to make a decision now. We've got our hurdle rates up here, and our hurdle rates are what we have to clear in order to say these things, this is true. If we pass our hurdle rate, we get to pass our null hypothesis. And you can technically make your hurdle rate anything, but people like to stick with 1, 5, and 10 because those are reasonable numbers. And if you're a pharmaceutical company and you're deciding whether your drug causes death or not, you want to go with 1% because then it's like crazy likely that your drug does not cause death if you clear it. But since no one's dying in ours, we're going to choose 5% because it's right in the middle and it's not hard to clear. But our textbooks have absolutely no correlation with being better. So in this case, we are going to have to not get the new textbooks. So
thank you for watching this episode of Math Notebook, where we learned real-life applications of the chi-square dependency test to see if one thing was dependent upon the outcome of another. We hope you enjoyed this episode, and if you did, subscribe somewhere over here. We're also going to put up each of the problems that we worked up here, the quick tip of the day, and other stuff around this area. Thank y'all for coming by.